Hello and welcome to 12th lecture in our comprehensive course on machine learning, data science and artificial intelligence. We were doing object-oriented programming and we said that it is a programming paradigm which is based on these four pillars. We have already discussed so far about encapsulation, inheritance, polymorphism. So now we want to discuss about abstraction. And then abstraction discussion is very short. So later on we will discuss one more example of object-oriented programming and quick recap of all four concepts will be done. Now, first abstraction. Let us write what is abstraction. It involves hiding the complex reality while exposing only the necessary parts. It helps in reducing the programming complexity and efforts. And in Python, the abstraction is achieved by using an abstract class which can't be instantiated and abstract methods which do not require implementation. Now, what is the meaning of this sentence? We always do it this way that I first speak the definition, but at that time things do not become very clear. Okay, so then we discuss some example and the meaning of the various phrases inside the definition that becomes clear. Okay, so hiding the complex reality. What is the meaning? We have already done this kind of case that suppose this is abstract class automobile and from automobile we are deriving child classes car, truck and bus. So this is an example of inheritance that we know that car is an automobile, truck is an automobile and bus is an automobile. So that is what we know. Now we can do one thing that even if it is a car or truck or bus, whatever vehicle it is, it may differ in some other aspects, but it will have at least some common traits. What common traits? If it is a vehicle, it must start, it must accelerate, and it must stop. So, what we can do is that there is no need to define these methods in each child class. We can provide that method in parent class itself, so that tomorrow I want to create a new child class, maybe car, bus and truck, so say pickup van. So to that also these three methods will be automatically be available because they are in the parent class itself and the pickup van will be derived as a child class of this class, the automobile. Okay, so this helps, but at the same time can we implement in the parent class? Then we will not implement because it may be possible that the starting mechanism, accelerating and stopping mechanism is different for car, truck and bus. So the implementation is done in individual child classes, or implementation of these three methods will differ based on for which object it is being used. So in the parent class we don't implement it, we just write only the necessary pieces of code, but we don't implement it. Okay, so that reduces programming complexity and effort. Now if I read this again, then at least some parts become clear. Hiding the complex reality while exposing only the necessary parts. So here we will just write the name of the three methods, but we will not do its implementation, because in any case for each type of vehicle you have to provide a specific implementation. Then why again implement here and then override it in the child class? So then this phenomena is called abstraction. We are saying that this is an abstract method in the parent class, this is also an abstract method in the parent class, and this is also an abstract method in the parent class. It helps in reducing programming complexity and effort, and for that Python provides an abstract class which is not instantiated, an abstract method which do not require implementation. What is the meaning? Let us take a code example, then things become clear. Okay, this sentence is important because suppose I first comment out that sentence and then I execute this set. You can see immediately error is triggered, that name abstract method is not defined. Okay, this abstract method whatever I have written in the parent class, that triggers that error. So what I have to do is I have to include this from ABC, import capital ABC and comma abstract method. Now what is this ABC? This ABC is short form for abstract base class, and Python by default has this available. So you don't have to write any definition for abstract base class. It is taken first letter of each word is taken, therefore it is called ABC, and from that this is an ABC object which is created from that for abstract base class. Okay, and then abstract method, okay, which is also imported from there. Now this class shape and then abstract method, and here you write def area self. Since it is designated as abstract method, Python will understand that implementation will not occur in this class shape, so we can just write pass. And then again the second one, perimeter. So every shape will have some area and every shape will have some perimeter. But we want to write different implementation depending upon the type of the shape later on, and therefore in the parent class shape we just write pass. This is the example of abstract method. Now this is the child class square which derives itself from the parent class shape, and it has one constructor. Now this, if you see this parent class, it does not have any constructor, and therefore this sentence that abstraction is achieved by using abstract classes which cannot be instantiated. If there is no constructor at all in the shape, then you cannot create an object of class shape. You can only create an object of class square, and that will automatically call the abstract methods which are there inside shape. That is a different matter, but you cannot independently create a new object of class shape. Okay, so it, because there is no constructor. But in child class you want to instantiate or create an object of square type. So therefore a constructor is required, and a square has only one parameter, one property, that is its length or side. So therefore self and side, and then self dot side, that is square dot side equals side. Again this is a dunder method, and that you have to remember. That means we can access it by providing dot operator. Okay, then this is area, another method, and we can write return self dot side square. Okay, again it is a dunder method, so that means it is square dot square is the name of the object dot side multiplied by side, and then perimeter. So perimeter for a square is clear that it is the sum of the four sides of a square, so that is why it will return 4 multiplied by square dot side. Okay, and then we will use it. Let us put that in a different now since I have written this statement, now this error will not be triggered, that name abstract method is not defined. So whenever you use this abstract method, then you have to include this statement. Okay, so run this, and now no error is triggered. Now I am creating an object square, say square 1 of which class? Of class square. Its constructor requires one argument, the length of the side of square. So I am passing 5. So that means that square 1 dot side equals 5. Okay, square 1 dot side equals 5. Then what it will return? It will return square 1 dot side square as area, and square 1 dot side multiplied by 4 as perimeter. But again it just returns, so that is why no output is triggered if I execute the upper one. But here I have to provide a printf statement. Then I can write square 1 dot area and square 1 dot perimeter. Okay, so area, if the side of the square is 5, then area is 5 square, that is 25, and perimeter is 5 multiplied by 4, that is 20. So this is the example of abstraction, that the area and perimeter methods are not implemented in the abstract class, base class. So we cannot instantiate the object from the abstract class. But in the subclass, area and perimeter are implemented, and here example of only square is given, but we have already done earlier same example that depending upon rectangle or triangle or circle, the methods will be differently implemented. Okay, so this is that diagram. Again, I just have to magnify it slightly so that you can read. Okay, so this is the example of abstract class and abstract method. And if you don't want to write import this statement, then don't write this also. If you don't write this and don't import that statement, then also no error will be triggered. But if you write this abstract method, then you have to include this statement. Let us check. What I'm saying is that now I remove this abstract method and I have commented out that import statement. Then you will see that it will work, no errors. Okay, and it will give the same result also. So you have two choices. That means that sentence is as such unnecessary. But if you want this, or for better clarity of code, if someone else is reading your code, then he will immediately understand that you are using abstract method, and therefore the implementation will not be there. Okay, so this is one thing. Now, as I said, we want to quickly discuss one more example in which we want to discuss all four concepts, that is encapsulation, inheritance, polymorphism, and abstraction. And we start with our well-known example, class vehicle, but this time we are providing some constructor. So this is this an abstract class? No. It can be instantiated easily by providing these two arguments, color and CC. And whatever color which you give, that will go here. So that means vehicle.color equals, say red you have passed, then is equal to red, and CC, suppose here you pass 1200 CC, and vehicle.cc equals to CC, okay, 1200. Now, then from that vehicle class, I am deriving a child class, that is the car. And it also has its constructor, and it takes three arguments, name, color, and CC. So now the question is how these arguments will apply. So name is totally new argument. In the parent class there is no name. So here you have to apply, assign that new argument as usual. self dot name, that means car dot name, equals whatever name you are assigning, say Mercedes or Jaguar or Maruti or whatever that. But these two attributes, color and CC, now will you again write self.color and self.cc? No, because they are already present in this super class. So then we can write this way, that super dot double underscore init double underscore. So this is a dunder method again, and color cc. So that means take this color here, take this color here, but don't assign anywhere inside the child class, but go to super class, because even a car is a vehicle which has a certain color and which has a certain cc. The advantage you can see that I don't have to implement these two methods for each and every different child class, because tomorrow I want to write another child class bus. Then will I write these two methods again separately, just like I will write two methods in car, same two in bus, then same two in truck, same two in pickup van? No, because all are ultimately vehicle and all are going to have some color and all are going to have some cc, that is engine capacity in cubic centimeter. Then you don't have to provide them in each and every individual class. You can just call this way, super dot initiator, that is a constructor, and color and cc should be provided to the constructor of the super class. Let us see if this works or not. I am trying to create this kind of car object. Maruti is equal to car object, and I have to pass three arguments: name, color, cc. So as a name I am passing Maruti. Where it will go? It will be assigned here. So self dot name equals Maruti. Then color, as a color I will pass this. So where it will go? It will come at this place. Okay, and from there it will be assigned at this place. So that means self dot color is equal to red, and then cc it will go here, but from that it will go to super class. That means it will be assigned at this. Self dot cc is equal to 1300. So it should print Maruti cc should print 1300, Maruti color should print red, and Maruti name should print Maruti. Okay, so let us check if it is printed. Yes, it is printed. Now let me create another car object, Tata car, and that again I use the same three attributes: name, color, cc, but this time name is Tata, color is black, and cc is 2000. Now everybody knows. Think a little bit. I will pause for a while. So think a little bit that where the Tata will go, where the black will go, and where this the 2000 will go, and then what will be the output of this. Okay. Okay. So Tata will go in this. That is self dot name equals name Tata. So self dot name will become Tata. This black will first go here in the child class, but it will not be assigned anywhere in the child class. It will go to the super class, and there self dot color is equal to black. And this 2000 also will go first to the child class, but will not be assigned. It will go to the super class, and then self dot cc is equal to 1300. Sorry, 2000. Okay. So let us check. Output of this should be 2000. Output of this should be black, and output of this should be name. And they are the output. Similarly, this one I am leaving for you. Another car object we are creating. This time name is Mahindra, color is white, and cc is 2500. You can try it. Now, the advantage you can see that we could create three car objects, but the real advantage is now clear that now I want to instantiate bus object. But for bus also, at least bus will also have some color, and bus will also have some cc. So class, I have written the base class definition once again so that it is visible on the screen and you don't have to scroll up and down. So then this is the base class, and this time the derived class is bus, which is derived from that. Now I am instantiating Tata bus. So bus equals Tata. The name will go here, and from here it is assigned. So bus dot name will be Tata. Okay, or Tata bus dot name would be equal to Tata. Fine. Then this color red would go first here, and there it will be assigned to this super class. So then Tata bus dot color would be equal to red, and Tata bus dot cc would be equal to 8000. So that sorry, I have to define the bus class, and you can see that same. This is Ashok Leyland, another bus for which you can pass these three arguments, and Ashok Leyland bus dot cc, this should print 7000, this should print yellow, and this should print it the name Ashok Leyland. Okay, and you can check that that is printed. Same is the case again. This time I am taking the base class vehicle, but I am instantiating truck class. So that I am leaving because it is very easy. This will print 8000, this will print blue, and this will print Tata, and similarly this will print 7000, this will print yellow, and this will print Ashok Leyland. Okay, so bus class, and you can see that that output is okay. Now explanation I have already given, so fine. How this does everything? So let us see that this example which we have taken, that explains all four concepts which are important in object-oriented programming. First, encapsulation. So this was our base class, right? So in the base class, when we got these two methods, these two assignments that is inside the constructor, then this attribute, which is now the encapsulated attribute. Okay, it is inside the capsule. Encapsulation means one capsule, attribute and method both are present. So here this is the encapsulated attribute, and this dash display info, that is the encapsulated method. Okay, so if I see, I can instantiate one vehicle object, and I can pass red and 1500. So red will go here, and therefore vehicle, its name is car object. So car dot color equals red, and car dot cc is equal to 1500. And then display info. Now this time the method itself contains print, so I just have to call that method. There is no need to provide a print statement to get the output, because the print statement is included inside the class definition itself. So car dot display info, and that is one way in which I can I can obtain the output. This is the right way to access encapsulated data. So we get the expected output, and display info function works. So these are encapsulated attributes, and this is encapsulated method. Okay, fine. Now, inheritance. Again, the above example, it includes the inheritance itself, because from vehicle class you are deriving a car class. So, but still, let us take another example. Class car, vehicle. So, class car inherits from the vehicle class, and class car has its own constructor, and it takes three arguments: name, color, cc. So, name is assigned inside that child class itself, but color and cc, they are, for that we call it the super class, vehicle class here, and color is assigned in the super class, cc is also assigned in the super class. We are trying to create, so this Maruti will go here, and therefore car dot name equals Maruti, then car dot color, that will be assigned in the super class, is equal to red, and car dot cc is equal to 1300. Okay, so that is what should be output in the display info, and you can get the output. So this is inheritance. The car class is the child class which derives itself from the vehicle class. Vehicle class is parent class. Okay. Now polymorphism. So polymorphism means methods do different things based on the object on which the methods are acting. So in this case, I take this bus class, and display info normally displays what? If I see vehicle class, then display info displays only color and cc. But suppose for the bus class, my mood has changed, and instead of color and cc, I want to display bus name and cc. Okay, so I want to, actually this is self dot name should be there actually, I think, yes, because otherwise, though it will print a bus name, but it will write it will display the color only. Hopefully, I think everything should work. So I'm instantiating one bus object, and bus is yellow. So yellow will go here, but inside here there is nothing for assigning color. So it will go to its super class, and in the super class vehicle class there is this bus dot color will be equal to yellow, and then I am providing cc. So actually I am not providing name. Okay, so then maybe this I think was not needed. So what will happen is the first will go, it will work correctly, give correct output, but implementation has changed. I will explain, don't worry. So bus name is yellow. The only thing which will change is, instead of writing in the parent class, the display info method was giving correct message that color is this much and cc is this much. But for the bus class, my mood changed, so I want to give wrong information to the end user. Okay, why anyone would want to do it? Forget about that. But I want to display color only in the output, but I want to write its name as bus name. And for engine capacity, I want to display the cc only, and here I want to write engine capacity only. So in the parent class, in the earlier display method, I was writing color and cc. But this time, same display info method is there in the parent class, but in the subclass, that is this bus class, I am redefining display info method, that is called overriding. And whenever you override a method with same name in the subclass, then the method of the subclass will always take the precedence. So even if the same named method is there in its superclass vehicle, that will not work, but this will work. and that you can check by the output that I get bus name yellow and engine capacity CC. If I do not provide any such overridden information, say I comment out this thing by that multi-line comment of Python, that is three single inverted commas. And now if I save and execute, now if I write this, now which display info method is being used? Then it is the display info method of the vehicle class. This is being used because in the child class or the bus class, I have no display info method. I have commented it out. So it will go to the vehicle class and it will display color is equal to whatever bus.color and cc is equal to bus.cc. Okay, so then it will display color yellow and cc 5000. But I provide a method of same name in the child class, then the above method of the vehicle class, this becomes automatically useless. I don't even have to comment it out. The precedence is like that if I give the same named method in the child class, then that method takes higher precedence and that becomes effective. This is called overriding of method, and that is one example of polymorphism. Okay, so again now you can see this output is obtained, bus name and engine capacity. Okay, abstraction. So abstraction means providing only some needed detail in the parent class, and implementation usually only required implementation is provided, but the rest of the implementation is provided in the child class. So this is vehicle parent class. It has its constructor. So I want that all vehicles are going to have color and CC. So I want to provide that much implementation. Self.color equals color and self.cc equals cc. But display info I want differently. If it is bus, I want to obtain differently. If it is a truck, then I want to display differently. So therefore here I am just writing pass. Now here if I write that thing, this is an abstract method. If I write that, then you have to import that from ABC, import small abc and all, import capital ABC and abstract method and all that. But if you don't write that, then that is Python automatically understands that you are not providing implementation. That means this is an abstract method. Okay. So now this is a child class, truck. Its parent class is vehicle. So everything in the parent class is automatically available to the child class. But this display info method, which was not implemented in the parent class, that I am implementing here. And this time I am not writing color, self.color and cc. Instead I write a few extra words, truck details, color, and etc. So how? Let us instantiate this and what will happen? Truck, blue and 3000. So where the blue will go? Blue will go because inside here there is no constructor itself. There is only one method. Okay. So blue will go in the parent class, and therefore truck.color will become equal to, or self.color will become equal to blue, and self.cc will become equal to 3000. This 3000 will go here and it will be assigned at this point. So this is how you can create a truck object. Now truck.displayInfo. Now which display info method will be executed? Then as such there is display info method in the parent class, but there is no implementation. So it is just an abstract method. But there is display info method whose implementation is given in the child class. So that will be. So what should be the output? Even before I execute this, output should be truck details, then color blue, capacity 3000. Let us check if that output is obtained or not. And okay, CC. I think everything is there. Maybe I just did not. Yes. So color blue and capacity 3000. That is the output. So that is the example of abstraction. That here method is just written, but it is not implemented. That type of method is called abstract method. Now here some exercise is there which you will try. These are a bit difficult exercise. So you are asked to a bit difficult, and you will get the solution later on. So you will try to do that. In next lecture, we will start with this topic: GUI building, graphical user interface building in Python, and libraries in Python. This lecture was a little bit long, but it was a good recap of the entire object-oriented programming. Thank you. We will meet in the next lecture.